In this video, we're going to explore the Maclaurin series for sine of x. So what we have plotted here is the blue curve represents sine of x, and the red dashed curve is representing our best approximation so far. So this one is the first degree approximation, which is of course just x. And you can see here that we can change the degree to anything up to 19th order. We are comparing the error as we change degree. So at the moment we have an error of 571.2%. And that error is measured at this point here. So when x is 3/2 pi and sine of 3/2 pi is -1, we're looking at the percentage error between -1 and the equivalent value on x. So that would be 3/2 pi. And that is 571.2%. And then we can change the degree. And as that changes, the curve changes like this, and we'll see here the next term appearing in the expansion. So now we have a better approximation around this area, and as it starts to curve around and represent the sine curve at the first turning points away from 0. The error has actually got worse. This is okay, this is allowed to happen. You can see again, this has shot down quite far because of the cubic order here. As we increase the order again, we'll see that we actually end up a little bit closer, but not as good as we had for the first order expansion. But you can see that the curve is much better represented close to 0, which is the main point of the Maclaurin series. Again, going beyond 5 and going to 7, we'll start to see this becoming much more accurate, and we're only at 260% now. And going further to 9th order will get us into a reasonable value at 55%. Increasing will get it even more accurate, and at some point this curve will be really nicely covered by the approximation around here. So we'll just see this error getting very, very small. So 8% at 11th order, 0.8% at 13th order, and it gets better and better as the degree changes.